still on circular motion. I'm going to take two more questions and then we'll move to something else under this topic, circular motion. We have a particle that is moving in a circle of radius 2 meters at a speed of given by v is equal to 3 times time. That is v is equal to 3 times t, where v is the speed in meters per second and t is the time in seconds. Now calculate the tangential acceleration of this particle after 1 second. We'll also find the total acceleration after 1 second. So what's the tangential acceleration of this particle? Now, first of all, we need to note that the tangential acceleration of this particle is given by the differential. When we differentiate the velocity, change in v, with respect to time, that gives us the tangential acceleration. So, and v is given as 3 times t. When we differentiate v with respect to time, we get our tangential acceleration. That is 3. That's when you differentiate 3t, it gives you 3. Differentiating t is 1. Then our centripetal acceleration, that one is dependent on time. It is given as v squared divided by r. Now, since we have to find that after 1 second, we'll replace this t with 1. That gives me my v as 3 times 1 over radius squared. That is, everything here will be squared. Yes, because v is 3 times t. The radius is 2 meters. It's already in a proper unit. So my centripetal acceleration will now be given as 9 divided by 2. That gives me 4.5 meters per second squared. That is my centripetal acceleration. So I have both my tangential acceleration and my centripetal acceleration. We cannot use this A, find the tangential. We cannot use this to find the total acceleration because, of course, we also call that the net acceleration. In terms of magnitude, the total acceleration or net acceleration is given by the square root of the tangential acceleration squared plus the centripetal acceleration squared. Okay, so that will give us square root of, what's my 80? 3 squared plus 4.5 squared. I have to apply my calculator here to compute this before I give the final answer. Okay, so that gives me 9 plus 4.5 square, that is 20.25 square root. So that the sum gives me 29.25. You take square root of that. So that my total acceleration, which is named as my net acceleration, is the square root of 29.25. That gives me 5.41 approximately meters per second squared. Okay, so quickly let's look at the last question on this so that I'll move to something else. Still on centripetal and total acceleration. Now here is this question. It says here the speed v of a particle moving in a circle of radius r varies with distance x as v is equal to kx, where k is a positive constant. We are to calculate the total acceleration of this particle. Okay, so how do we solve this? Is it in terms of x? We shall find out. But we are given the speed, how it relates with distance or displacement. So v is equal to k times x. K is a positive constant. So to find the total acceleration, which is also called the net acceleration, is we're going to use that's in terms of only magnitude, the square of the centripetal acceleration plus the square of the tangential acceleration. You add the two squares together and take square root of the sum of the squares. That gives you the net or the total acceleration of this particle. Now let's work our way through this. So that I have AC is given as v squared divided by r, the radius of the circle. Okay. Now we're given v. Okay, we can say that our v is given as kx from the question. V is related to distance by that expression. V is equal to kx. X is not given, k is not given. Okay, so we'll just square this and put our r there divided by this. So that gives us k squared x squared divided by r. So that's the expression for centripetal acceleration. Then for the tangential acceleration, it is given by the derivative of the speed with respect to time. Now you can see here that the speed v is a function of the displacement. It's not a function of time. So how do you differentiate this with respect to time when it is not a function of time, when v is not a function of time? It's what we call um, to differentiate this tangential acceleration, which is the v over the t, and then we need to differentiate with respect to time, but the velocity given is a function of displacement or distance. So in differential calculus, this can be done by splitting this into the v over dx multiplied by dx over dt. Now check this expression. You can see that this over this is not far from this product or the product of these two derivatives, because this will tend to cancel out this. So you go back to your dvdt. I think it's more like a differentiating, like a parametric differentiation. Okay, so here now what do we do quickly? We'll differentiate this with respect to x. That gives us k. We'll replace with k times. Now dx dt is same thing as v, because this is displacement over time, which is velocity of speed. So this is my tangential station at, which is the product of k and this. And remember that k or v itself is same thing as the product of kx. So that gives me k dot k times kx. So that my tangential acceleration is same thing as k squared times x. Okay, this is my tangential acceleration. So the next thing is to substitute both expressions. Let's call this equation 2. Let's call this 1. Expression for centripetal acceleration and tangential acceleration. You put them in the equation for the total or net acceleration of the particle. That gives us an is equal to square root of the square of this. That is k squared x squared over r, all squared again, plus this gives me k squared x all squared. That's for my um, tangential acceleration. Okay. The next thing is to evaluate what we have here. Okay. So we can move to a different page to continue my evaluation. So I have how to simplify this expression. No, not just to explore. Okay. Okay, so that's why you have this. And then the next thing is for you to simplify this expression. Let's move to a fresh page to help me simplify this expression. So I have total acceleration equals this. This gives me k squared, k raised to the power 4, because square of this is that. Applying the law of indices, x squared squared, that gives me x4 over r squared plus my k squared or k4 times x squared. Okay, so you know that the square root of k4 will be k squared. The square root of k4 also be k squared. So that can be factored out as k squared. Okay, the square root of x squared is x. The square root of x4 is x squared. So I can factor out all. Let's write it that way. That gives what is left here is x4 plus x2 divided by r squared. Okay, I can decide to simplify further by taking the LCM. This is over 1. This is r squared x4 plus x squared r squared. So that is in terms of the symbols I have, the expression for my total acceleration. Okay, so if I factor out x squared from this, I can have x squared plus r squared. divided by r squared. That is square root of that multiplied by k. So eventually, what I want to have the square root of x squared is, so I want to have kx square root multiplied by square root of what? X squared plus r squared divided by that r squared. And the square root of r squared is r, so that can be taken out of the square root sign. So I have this as the expression for my total acceleration. So when all the parameters are given are known, I can easily find the total acceleration of the particle. I hope this is clear.